Hello and welcome back. We are in day 2 of Mule Advanced Playlist. So today we are going to understand about Mule Runtime Engine internals. So we'll understand about how Mule Runtime Engine internally works and how it is internally using reactive programming model. We'll discuss about various thread pools which are used by Mule Runtime Engine, like Grizzly thread pools, and how non-blocking IO works and how thread pools internally work in case of transactional flows and non-transactional flows. So let us get started. Uh, Before I get started with reactive programming model, let us talk about how thread pools work. What is a thread pool? I will try to elaborate it because some of you might not be knowing about how thread pools actually work. So I will talk about this and then we'll go into the details of reactive programming model. Normally, whenever we are running a Java program, how to run a Java program? We use a command Java space class name. This Java class, whatever we are writing, will contain a method called as main method, where we write the logic that will be executed. So actually, whenever I run a Java application, what will happen? Java virtual machine will be started, JVM. JVM is nothing but an operating system process. Okay. You can see in your operating system processes, you will be seeing JVM as well. JVM is nothing but an operating system process. Whenever we run any Java application, first a JVM will be started, a process, and inside JVM, this operating system process, there will be a thread which will execute the main method. By default, one operating system process will have at least one thread to execute the logic. Thread in a process will execute the logic. But one process can have multiple threads, okay, running concurrently. So inside JVM, we can have multiple threads running concurrently. Okay. So what we can do is, in my main method, if I am writing some Java code, there is some specific procedure to actually start a new thread. In your code, you can also start a new thread. But whenever a thread starts, what logic it has to execute? A thread will always execute some logic. And once the logic is executed, it will terminate. So as a developer, how do you tell what is the task to be executed when a thread starts? Okay. So what we do is we write a separate class implementing an interface called as runnable. Okay. So quickly, let me show you the Java code. If you are not from Java background also, just understand the concept. You will never write coding in Mule, but this is just to make you understand about a concept, how a thread will be started. So I will write a class just to show you. In a package, some package as test, and here I'll write task, my task. So what we see, I have to make this class to implement an interface called as runnable. I have to implement my logic inside run method. This is executed in a separate thread. Just I'm writing like this. So whatever logic you want a thread to execute, you have to write that logic inside run method. Okay. Now I will write another class with main method. Just I will write a class with name test and main method. Now here I'll just write inside main method. Okay. Then I want to start a thread which will execute this task. I will create this task object. My task is equals to new my task. Okay, I created an object. Then I want this task to be executed in a separate thread. So what I have to do is there's a class called as thread, new thread, which will take, there is a constructor which will take a runnable object. So can I pass the task? Yes. So I'm creating a thread. Then to start a thread, I just have to call t.start. That's all. This will start a thread. Or simply, I will just call here itself dot start. Fine. I want to start 10 threads. I want to start 10 threads. So what I will do is, I will write in a for loop for int count is equals to 0, count less than 10, count plus plus. So in a loop for 10 times, I am executing this logic. So 10 threads will be started. And after the for loop, I will write after starting threads. Hey, now what I will do is, here in the task, I will simulate a logic that this thread will take at least 2 seconds for completing. Every thread, when it starts, I want to simulate that it will take 2 seconds for coming out of run method. So there's a method just to show you thread.sleep. I want it to sleep for 2000 milliseconds. Okay. Here again, exceptions I'm handling. Don't worry if you are not a Java guy. If you don't know basic of Java, this is just very basic of Java. We're handling exception. Fine. So once any thread starts executing run method, it will first go into sleep mode for 2000 milliseconds, and then it will print this. Okay. So now let me run this test. I will just run as a Java application. So what will happen? A JVM will start, and inside JVM, main thread will execute the main method, and the main thread is starting 10 more threads. Okay. So I started this application. Let us wait. So I should see first the main thread will execute this. Then it is starting 10 concurrent threads. And then it will print this. What is happening? Yeah. See, inside main and after starting threads. Oh, actually, I started threads, 10 threads. Output of 10 threads, I'm seeing a little late because after thread starts, I'm making it sleep for 2 seconds. After 2 seconds, I'm saying this. So main thread started 10 concurrent threads, which will run concurrently on my CPU. Okay. So these are we start threads. But here, what is happening is I am starting 10 threads. Once a thread starts, what it will do, it will execute this run method logic. And once the control comes out of run method, the thread will terminate. Okay. So actually, for every operating system to start a thread, it has to do a lot of things internally. So for every new task, if you want to start a new thread, it is costly for operating system, costly in terms of the CPU time it takes. So the thing is, if you want 10 threads, if you want the logic to be executed concurrently, for every task, why to create a new thread? Why can't we reuse a existing thread? Right? Just like in our projects, in our company, what they do, whenever there is a new project, will they hire a new employee every time? No. What they do? They might be having some employees on bench. So whenever they want a resource for a new project, they will take from the bench, use them, and once the project is over, again the employee will go to bench. Maybe another project will pick you, and you will work on that project, and again go to bench. So instead of hiring a new employee every time, whenever they get a new project, what they do is they maintain a pool of resources, bench, we call it, right? So reusability, basically, instead of hiring. If I have to hire a new employee every time, there is a process, there's a overhead, right? So I can say that bench is a pool of resources, right? Similarly, here also, why should the operating system start a new thread every time? Why can't it reuse the threads? So there comes the concept of thread pools. Okay. Actually, if you have to write the logic to pool the threads, to have a threads in the pool, you have to write a lot of logic. But there are libraries in Java using which we can actually configure and we'll get a thread pool. Okay. So what those libraries, how those libraries are implemented? Hmm? So actually, in whenever any thread pool is implemented by a library, they use this pattern. For every thread pool, there will be one in-memory queue. Queue is a data structure, you know, right? First in, first out. You can put any element in the queue, n number of elements in the queue. First element which is in the queue will be retrieved from the queue. So in every thread pool, there will be a queue called as task queue. Okay. What do I mean by task? I showed you, right? Here. Any class implementing runnable interface is a task in Java, right? So, uh, whenever you want to submit a task to thread pool, what you do, you create a task object. Task object means a class implementing runnable is a task. So you'll create objects of this class of the task and put it inside the queue. Okay. So whenever a thread pool is starting, the library might have written logic to start some threads which will run continuously in a loop. They will write some logic to start threads which will run continuously in the pool. So we can just configure the thread pool and specify what are the minimum threads to be running in the pool. Assume that minimum threads I will configure as 5. So when my application actually starts, 5 threads will be started, right? What these threads will do is they will call queue.remove. They will try to fetch tasks from the queue. All the threads, when they start, what they do, they will try to fetch a task from the queue. Assume that there are no tasks in this queue. You wouldn't submit any task in this queue. What? All the threads will be blocked or waiting for any task. They are blocked. They will be in blocked state or waiting state, waiting for a new task to be coming into this queue. So in your logic, whenever you want to submit a task to the thread pool, what you do? You just have to create a runnable object and place it here. Place it in the thread queue, task queue. Okay. So there are 5 threads, right? Whenever you put a task in the queue, one of the thread which try to retrieve from the queue first, it will retrieve it, execute the run method in the task. Task will have a run method, right? And then once the control comes out of run method, again this thread will look for a task in the queue. Okay. So like that, the threads minimum I said 5, right? These threads will never be terminated. They will look for a task in the queue. If there is a task, retrieve the task, execute the run method inside it. Once the control comes out of run method, this thread will not be terminated. Again, it will look for a new task. So like that, in a thread pool, if I just configure, I want 5 threads minimum. Minimum 5 threads will be maintained by the library. Okay. But what if at a particular point of time, I submitted 5 tasks into this queue? 5 threads have picked a task. 5 threads are still executing the run method. It is taking. Assume that the logic, whatever we write inside run method, is taking 10 seconds. So each task takes 10 seconds. So assume that at a particular point, there are 5 threads and there are 5 tasks I submitted and 5 threads are busy. Now, assume that in my logic, I submitted 6th task. What? All the threads are busy, right? Now I submitted 6th task. So it will take some time, right? So what we can do is we can configure max threads. So assume that max threads is 10. What will happen if all the 5 threads are busy? Then as I configured max threads in the pool is 10, one more thread will be created and added here. And that thread will take 6th task. So now in my pool, 6 threads are there. Now like that, the threads can increase up to maximum 10. Okay, good. Now, What will happen at certain point of time? There are 10 threads, but no tasks in the pool. There are no tasks in the pool. All the tasks are already taken. Now the thread pool size has grown to 10, right? All the 10 threads are are idle. They are not doing anything. So why should I have 10 threads idle? Right? So like in the concept of bench in our companies, if more employees are coming to bench without any work, the company will be under loss, right? So I think most of the companies say you can be on bench for 3 months. If you are on bench for more than 3 months, they will terminate you, right? Similarly, here also in threads, we have something called as time to live, TTL, time to live. Suppose if I configure 5 minutes, that means if a thread is idle for 5 minutes, a thread will be removed from the pool. A thread will be made to terminate. That is the logic they have implemented. But at any point of time, minimum 5 threads will be maintained, right? Maximum 10, and every thread will have a timeout. And these threads are called as worker threads. They are the actual one who will be executing the work or doing the work, right? Normally in a thread, we call them as worker threads. I hope now you got a clear understanding about how thread pools internally work. Okay. Any questions? Let me know. In the concept, idea, then we'll jump into the reactive programming model of Mule Runtime. Any queries? Let me know. Okay, fine. We are going to a very important topic now. Reactive programming model. Actually, there are multiple ways to write program. There are multiple approaches to write any coding. Reactive programming is approach. This is a style of programming, reactive programming. Actually, if in Java, if I want to write the code using reactive programming, there is a specification called as reactive streams. Reactive streams is a specification in Java. And for this specification, there are implementations. Java RX is an implementation of reactive streams specification, and project reactor is another implementation of reactive stream specification. This project reactor, we can say it is a reference implementation. And there's a popular framework called as Spring Framework. And Spring Framework is internally using Project React for its reactive programming. And if you know, Mule is internally developed on top of a framework called as Spring Framework. So Mule is internally using reactive streams and it is internally using reactive programming. Okay. So let us understand about what is this reactive programming and how it works. Okay. Whenever you are writing reactive programming code, you will be implementing a pattern, design pattern called as observer pattern. Okay. What is this design pattern? Observer pattern. If you are implementing this pattern, there will be two objects. One is an observable object and another is observer object. Okay. Just a minute. Yeah. So actually observable and observer, there will be two objects. What observer will do is it will subscribe to this observable. Okay. For one observable object, there can be multiple observers subscribed to it. Okay. Now, assume that this observable object is observing for any changes in my database. Whenever there is a new record added in my database, assume that I have written a logic to observe if there are any new records in my code, right? If there is any new record added into the data, a particular database table, this observable object has some new data. So it has to notify all the observers. So what this observable can do is actually it can notify the observers. Actually, there will be one thread which will be polling the database to check for new records, right? So normally when implementing observable pattern, what can happen is this thread which is polling the database, once it gets any new record, the same thread can invoke the observers or notify the observers. So single thread has to execute all the observers. What if there are 10 observers or many observers? Same thread has to execute first observer. Once first observer is executed, second observer, third observer, fourth observer. What if each observer execution takes 5 seconds? How much time it will take for the main thread to execute all the observers, 5 observers in this case? 25 seconds it will take. So whenever there is a new record here, it will take 25 seconds for this main thread to invoke all the observers. But instead of that, what we can do is we can use something called as a scheduler. Scheduler. And for this scheduler, I can configure one thread pool where in a thread pool, we can specify how many number of minimum threads, right? So there will be a thread pool which the scheduler will be using. Okay. Now, whenever a observable thread gets a new record from database, instead of the main thread executing observers, the main thread will give the task to scheduler and ask the scheduler to schedule the task. My logic, what it will do, it will submit my task to scheduler and ask it to schedule the task. The scheduler will submit it to the thread pool, right? Hey, I hope you remember when I said submitting to thread pool means every thread will have a task queue. So runnable object is kept inside this queue. A threads from the thread pool will pick up, right? So now if my thread pool is having 5 threads, what will happen now in this case? Whenever there's a new record added into database, this main thread will pick that data, create a task. That means create a runnable object and give it to scheduler. Scheduler will submit it to the thread pool. So there are 5 observers, right? What can happen? 5 threads from this pool can actually execute all the 5 observers concurrently so that it will take approximately 5 seconds to execute all the observers, right? Now, once you understand about it, about scheduler and thread pools, let us go and see in Mule how this is used. Okay. But before that, one more thing I will tell you. This is observer, and this is observable, and this is observer object. Assume that there are multiple observers, and assume that whenever an observer is given a task, whenever observer is given a task, it will take some 5 seconds, right? Now, assume that this observable is, I hope you are able to hear me. Uh, 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 Assume that this observable is pulling for data from the database, and whenever there's a new record, it has to execute observables. Assume that at a particular point of time, there are 100 records in database. So for each record, it has to execute the observer, right? So what this observable can do is observer will observable will give 100 tasks to scheduler, and assume that the scheduler is backed by a thread pool. It will submit it to threads. Observable will be actually invoking the observers through these threads. Now, there are 100 records, right? This observable will try to push 100 records to observer. It will try to push 100 records to observer. But for each record, it will take 5 seconds. The observer is a little bit slow. So what this can do is, it can tell to the observable, hey, don't push more than 3 records per second. I can actually consume only 3 records per second. If observable is trying to push a lot of records, observer is slow. For every record, it takes 5 seconds. Assume it has a capacity of 3 records per second. So what? Observer, there is some configuration. Observer can put a back pressure on the observable. We are using a term called as back pressure. And the observer can tell, hey, I cannot take more than 3 records. Don't push more than 3 records. So accordingly, the observable will not push more than 3 records. Right? So understand about what is a back pressure. Who can put a back pressure? Observer can put a back pressure on the observable. Okay. Okay. Now, once you understand this, let us go into Mule. So assume that in a Mule, I am writing a flow. This is my flow. Assume that in my flow, I have a HTTP listener. And after that, I have a database select. After that, I have a transformer. After that, I have a logger, writing some log, set payload, setting some payload. That's all. This is my flow. Now, in every flow, I hope you remember, the first part is called as message source. This part contains a source which will receive the messages. In this case, HTTP listener is a source of my flow. Whenever a HTTP request comes, the listener will create a Mule event, and give the mule event to the rest of the flow, right? Okay. This HTTP listener will be internally using a framework called as Grizzly. We'll talk more in detail about Grizzly next. So this HTTP listener will be using Grizzly internally. And of course, Grizzly uses its own thread pool, Grizzly thread pool. There will be threads maintained by this Grizzly. So there will be thread pools. So I hope you know, whenever we get a HTTP request, if there is a single thread which is handling all entire requests, it will not work. So what actually happens is where there will be one thread which will be listening for requests. Once any request comes, this thread which is listening for request will delegate to this thread pool managed by Grizzly. So one of the Grizzly thread will actually process the request. There will be one thread which will be just listening. Its work is just to listen for requests. Whenever request comes, the main thread, this HTTP thread, will submit it to the thread pool. So one of the thread in this pool will, what it will do? It will create a mule event, right? In mule, whenever a HTTP request comes, a mule event object will be created, right? Who will create this mule event? Whenever a request comes, a thread from the Grizzly thread pool actually will create a mule event. Okay. Now this mule event which is created has to be given to next component. How it will do it? Actually, at mule runtime level, there will be three schedulers. There will be three schedulers at mule runtime level. First scheduler, we call it as CPU light scheduler. Another scheduler, these are all schedulers, okay? There will be three schedulers at Mule runtime level. CPU light scheduler, CPU intensive scheduler, and IO scheduler. Each scheduler is backed up by a separate thread pool. Each scheduler has its own thread pool. This thread pool, we call it as CPU light thread pool. This is CPU intensive thread pool. This is actually IO thread. Okay, there will be three thread pools and three schedulers, right? Now, the HTTP listener has got a request. It delegated to Grizzly thread pool. One of the thread from the pool will create a mule event, and that mule event has to be given to the select component. What type of operation is this select component doing? It is firing a query on database, right? It needs to read from database. And if I ask you what type of operation is it doing? It is doing an IO operation. IO means input output. Reading and writing, we call it as IO operation. So select component is actually an IO, the IO component. It is doing IO, input output. It is reading and writing. So actually in Mule, somebody might have developed the code for select component, right? They have annotated it with IO because they know that it will be performing some input output operation. And what about transformer? Will it do read and write? Mostly. No, it will contain transformation logic, which will be executed by CPU. So can I say that transformer will do CPU intensive logic? Yes. And logger is just writing a log. it is just doing a light operation. It will not consume much CPU. Set payload also, it's just setting the payload of Mule event. It is annotated with light. It is doing light operations. It will not take much CPU. So basically in Mule, every component is annotated with either IO or CPU intensive or light based on what logic they are doing. Now, coming back here, this HTTP listener has got a request. What it will do, it will delegate to Grizzly thread pool. One of the thread from this pool will create a Mule event, and then it has to invoke the next component. But it will identify, okay, the next component is IO. It is of type IO. So what it will do is this HTTP listener will submit the task to IO scheduler. The HTTP listener will not invoke, this thread will not invoke the select component directly. So it will submit the task to IO scheduler. IO scheduler will internally use its corresponding thread pool. So one of the thread from this IO thread pool will execute the select component. Okay. Now select component, once it is executed, then the event has to be given to transformer. But again, transformer is CPU intensive, right? So what will happen? The task will be submitted to CPU intensive thread pool. Now a separate thread from the CPU intensive thread pool will execute the transformer. Okay. Then assume that again I have some insert. Insert. So again, insert means what? IO. Insert component I have. Assume that here I have insert component. So it's IO. So now what? The transformer will submit the task to IO pool. One of the thread from the IO pool will execute the insert component. Then the next one is logger. So it is CPU light, right? What will happen? A task will be submitted to CPU light thread pool. And one of the thread from the CPU light thread pool will execute this logger. So like that, based on the component, the corresponding thread pool will be used, right? But too much of thread switching, right? In one flow, there will be there is too much of thread switching. To again, if you are having too many thread switches in your code also, it might not be good for performance. So to improve performance, what they have done in Mule is in a flow, at the last of the flow, if there are light components, if there are light components at the end of the flow, what will happen? They have designed Mule in such a way that the previous thread, the thread which is executing the insert, that means IO, same thread will execute all the light components. Only it happens only if the light components are at the last of the flow to avoid thread switches. So same thread will execute the logger and set payload. Okay. Now, one more thing I want you to understand here. By default, in Mule, the CPU-led light thread pool is configured to have fixed thread pool size of 2 into number of cores on my machine. So if my Mule runtime is running on my laptop, I have an octa-core processor, 8 cores. So how many threads will be there in CPU light thread pool? 2 into number of cores on your machine. 16 threads will be there in CPU light thread pool. Similarly, in CPU intensive thread pool, there will be 2 into number of cores. So again, in CPU intensive thread pool also 16 threads. But for IO, see, IO, that means reading and writing will take more time, right? So more number of threads are required. So there is some formula which Mule Runtime uses to actually calculate how many threads can go inside this IO thread pool. I will show you that formula. So by default, this is the behavior, right? Now, let us see with example. Let us see with example how various threads are involved. Hmm? So, one thing is uh, before Mule version 3.2, I guess. Sorry, 4.2, I guess. This is how there are three thread pools. One CPU light thread pool, CPU intensive thread pool, and IO thread pool. So before Mule runtime version 4.2, this is how it was. But after 4.2, they changed the behavior. They thought, hey, why should we maintain three separate thread pools, CPU light, CPU intensive, IO? They thought like this. It is a maintenance overhead. So why can't we have a single pool which all the schedulers will use? That is idea which was good actually. So starting from Mule version 4. I think greater than some 4.2 version, they removed all these individual thread pools and they came up with a concept of Uber pool, one bigger pool. So anyways, we want thread switching. All the schedulers will point to same pool. Why should we have three pools? So with that idea, this Uber pool is created. And I guess this is after 4.2. Right now, we are using 4.4 version of Mule Run. Okay, fine. Let us go to code and see how actually threads will be working. Okay. Now, I will import a project which I have. I will import this star. Okay. I'll explain you. I will go to file, import, packaged Mule application jar. Okay. Finish. Okay. So here, this project I imported and have some logic here. I'll explain you. This flow is having HTTP listener, which is listening on a default port slash wait slash test. Then I have a logger component. Logger is actually CPU light, which is just printing. Got a HTTP request plus payload. Okay, I don't want payload right now. I'm removing it. It will just got a HTTP request. Then my select component, it is an IO component. It is firing select star from product. Which database it is connecting to? It is connecting to Mule training DB test connection. Just wait. Cancel it better. Yeah, it will work actually. This database is there on my machine. Okay. Now, after firing a query, we'll get list of products. Simply my next transformer is just having some transformation logic. In transformer again, I'm using a function called as log to write a log. What this log will do is log will take two arguments. Log function will take two arguments. First is a string and second is any object. It's also of course a string. So what log will do is log will concatenate both the two arguments. Okay. And it will write a log by concatenating these two. But it will return the second argument. Okay. In the logs, I will see a concatenation of this. That's all simple. So I have written some transformation logic. And here I have insert, which is maybe inserting into database. Some hard-coded values I'm inserting. Then again a transform message component, which is just converting the output to JSON. Then set payload. Again, here again, I'm writing some logic so that I can see some logs. Okay. What is this var.my result? I guess here I'm storing the output of this transform message in a variable called as my result. Then I'm setting here, right? This log function will write a log by concatenating both, and we'll just return this result. Then logger again, it is just logging after inserting. That's all. Now this is the flow. Let us observe the thread pool behavior of this flow. This is a light component. This is IO component. This is CPU intensive component. CPU are light components, CPU light components. Now let me run this application. We'll observe the thread pool behavior right now. But before that, I will show you some important configurations. Yeah. Firstly, let it start. But here you can see Mule Anypoint Studio is using Mule Runtime, which is actually as a plugin. This is the path of Mule Home, right? Let me go into that. This is the Mule folder which is used by Anypoint Studio. So I need you to understand about the thread pool configurations. In Mule Runtime, you can see there's a conf folder, and here I have a file scheduler pools.conf. This is the place where we configure the pools. So I will open it. You can see here there is some configuration called as mule.runtime.scheduler pool strategy is Uber. Here the comment says this specifies a strategy to be used for managing the thread pools backed by three types of schedulers: CPU light, CPU intensive, and IO. There are only two possible values, Uber and dedicated. So here they are saying when the strategy is Uber, all three scheduler types will be backed by one Uber thread pool. And this is the default starting from Mule version 4.3.0. Before that, the default one was dedicated. So in this case, if you are configuring dedicated, each scheduler type is backed by its own thread pool. Okay. So it is configured as Uber, right? For now, I will change it to dedicated. Just for explaining it, dedicated. So when I configure dedicated, what is the configuration for dedicated thread pool? If I come here down, here is a configuration for dedicated thread pool strategy. Okay. Here you can see there is a configuration. What? org.mule.runtime.cpu dot thread pool size. Thread pool dot size. What is it? 2 into number of cores. For which CPU Lite? This is CPU Lite thread pool configuration. By default, it is configured as 2 into number of cores on the machine. And worker queue. I said for every thread pool, there will be a queue, right? There can be a capacity for this queue, maximum capacity for this queue. So if this queue is configured with size 10, 50, 50 is a queue size, but maximum threads here is 10, minimum threads is 5. Maximum number of threads of this pool is 10. That means if you are using this thread pool, how many tasks can be executed concurrently? Maximum. Max threads are 10. Maximum 10 threads are executed, right? 10 tasks can execute concurrently. So max concurrency, if I ask you in this case, what? 10 only. Maximum number of threads. Okay. But this thread pool can handle or can accept how many tasks? See, 50 tasks can be queued in the queue, right? 50 tasks can be in the queue. And 10 tasks might be already picked up and 10 threads are using. So 50 plus 10, 60 is the capacity of this thread pool, max capacity. That means queue size plus max threads. So 50 tasks are lying in the queue and 10 threads might be executing some extra 10 tasks. 60 is the capacity of the thread pool. So every thread pool can be configured with a capacity, max capacity. So what if I want infinite capacity? If I configure the task queue size as 0, that means it is infinite capacity. N number of tasks can be queued into this, right? So coming to the configuration here, in the CPU Lite thread pool, the max size and core size are same. That means this thread pool is a fixed size thread pool. There will be no min and max. Fixed size thread pool. CPU Lite thread pool is a fixed size thread pool. It will contain 2 into number of cores. And what is the worker queue size? 0. Okay. Then for IO strategy, for IO thread pool, the minimum core size means minimum size, is equal to number of cores. But max size, io.threadpool.max size, I told that it will be using some formula which is based on cores and memory, etc. And queue size is 0. Similarly, for CPU intensive thread pool, you can see the number of threads is 2 into number of cores and worker queue size is 2 into number of cores. This is the configuration in schedulerpools.com. Right? Now, I configured the scheduler pool strategy as dedicated. By default, it was Uber. Now I configured it as dedicated. So, hey, anyway, I changed the configuration, right? I saved it, I guess. Yes, I saved it. Right. I want to save. Okay, it's already saved. Fine. Now I'll restart. I want you to observe the console. Yeah. Let this be happy. Then I will show you. Now Mule Runtime is starting up. It will also write some logs. Let us see. So I wanted you to observe the logs. Yes, here you can see started default scheduler service and pooling strategy dedicated. CPU Lite thread pool size is 16 because I have 8 octa-core processor. CPU worker queue size is 0. Info thread pool max size is 164. I told you that it is using some formula, right? What is the formula? Max size of wait, max size here, yeah, here for IO thread pool max size. This is the formula based on the memory available to my JVM and based on number of cores. Right now, you can see that the value here is 164. Which might be different on your machine based on the memory available and number of cores. This is actually using some formula. Similarly, CPU intensive thread pool size is 16, worker queue size is 16, all this. Fine. Now, I will clear the console. Now, let me give a request and explain you. This HTTP listener is listening on /test. I will give a request to localhost 8081/test. I gave a request. I got some response, don't worry. Now, I want you to observe here the console. See, HTTP listener, once it gets a request, it will give it to logger, right? Let us observe the logs. Actually, in the logs, internally Mule is using a framework called as log4j or logging, right? The log4j, whenever it is writing the logs, here you can see it is configured. This is the thread pool name. This is the thread name, actually, not thread pool name. This is the thread name. In the logs, automatically the log4j framework will actually get the thread name. Every thread will be given a unique name, and this is a thread name. You can see that the thread name is something like CPU Lite.16. This is the thread number in the pool, CPU Lite pool. Thread number 16. You can see this is from log message processor, got a HTTP request, right? So logger is executed by which thread? CPU Lite thread. Okay. After logger, I have select component. Select is an IO component. It will do read write. So you can see this is the logs from actually the select component are executed by IO thread pool. IO707 is a thread number. Then after that, I have transformer, which is having some logic. So here in transformer, I was writing got PID as concatenating. This in a loop I have written. I have used map function to actually loop through each product, right? And I'm writing the logs. So here you can see 6 logs because there are 6 products. All these logs are coming from which thread, are executed by which thread? CPU intensive one. Okay. Then next one is insert. Insert is IO. So here you can see IO. This is thread name. Then again after that, transform message. Sorry. So transform message is CPU intensive. So you can see the logs from CPU intensive. But Set payload and logger are CPU light and they are at the last. I told you to improve the performance. If the last components are CPU light, no more thread switching. Whatever thread has executed this transform message, it will execute. See, these are the logs from set payload and logger. So same thread CPU intensive 02, it has executed the set payload and also the logger. Fine. So that's how you understood how thread switching is happening. Right. Now, simple, if I actually change my strategy to Uber, the default one, there'll be single thread pool, but three schedulers are there still behind the scenes, which will take care of scheduling, right? So Uber is a single thread pool behind the scenes from 4.3.0 Mule version, right? So this is the configuration and how thread pools behave. Now, too much of thread switching, right? What if your logic is having some transactions? Will the thread switching happen even if your flow has a logic for transactions? Let us see how the same thread pools behave in case if you are having a transaction in your flow. So I will show you an example of transactions. I will just give you an idea about how transactions work in Mule and how thread pools behave in case of a transactional flow. We'll see. Let me import this project. Mm, yeah, I have one more project which has transactional logic. I'll explain. So if you see what I am doing is just a minute. Mm, what I will do is right now, here in this flow, what I'm doing is I'm using on table row to pull for any new product, for any new product um, in product table. And what is the frequency? After every 5,000 milliseconds, it will pull the database table. If there is a row, now let me go to my database. Fine. In Mule training DB, I have product table. I will truncate the table. Oh, I will maybe drop this table and I'll right now truncate. Fine. If you see right now, there are no products. Okay. So in training DB product, there are no products. I will insert a product next. Okay. So here, if there is a product on table row will trigger my flow. Here at transform have I'm having a try block. I'll tell you what I'm doing in try block. Here I have a transformer, which is actually getting the data and creating this JSON. Okay. In the transformer, I'm just writing a log. What this log method will do, log function will do in data wave, two arguments, one is string and second argument. Whatever is the second argument, it will be returned. But while writing the log, it will concatenate first argument, second argument, and write the log. That is how log function works. So in my transformer, I'm transforming to JSON. Then insert component. It is inserting into DB1. Okay. I will remove this DB2 actually. There is DB1 configuration which is pointing to another database called as DB1. Okay, let me check if I have DB1. Yes, here I will truncate these tables as well. Okay, so there are two tables. Product table, right now it is empty. Copy product table also, it is empty. So this is DB1. Fine. Now coming to here, we are polling for new records in Mule training DB. Okay. Once we get any record, transformer is converting the record to JSON, and we are using insert to insert into DB1 into product table. Whatever values are there, I am inserting, and I'm again having another insert, um, which is inserting into another table, just a dummy table, copy product table. Both are having same structure. Right now, both are empty. Okay, fine. Both are empty. Now, I'm inserting into copy product table. Then, what I will do is I'll just drag it here. And now, if transform message component, what I'm doing, see here. Oh, let me show you this transform message component. What is it doing? It is also storing a variable, creating a variable called as bname by extracting the brand name from the incoming data. And here in this transformer, I'm checking if vars.bname is equals to Samsung, just simulating an error condition. Here there's a function called as fail function in DW colon runtime module. There is a fail function which is just throwing an error. We don't accept Samsung. Else it will just return. So I'm simulating a error condition, right? So this is inserting into product table of DB1 and this is inserting into same database DB1 but copy product. Now logger is just writing inserted error. Now let us actually work without any transaction. How to work with transactions, I'll tell you just a minute. Okay, these are the components. I will remove this try scope. Now, actually, there is nothing like a transaction. As usual, we have this flow. There is no transaction right now. Let me run this. So whenever there is a new record, flow will be triggered. I want you to observe what will happen. Application is deployed. Now this on table row will be polling the database at regular intervals. Here actually, you can see on table row is a source, right? Some thread will be polling. Actually, I have enabled debug level logs in this project. So you can see the debug level logs where it is showing the log, what is the query it is firing internally. Debug level logs are enabled. How did I enable debug level logs in my log4j2.xml? Here, what I have done is there is a configuration level equals to debug. By default, it will be info log. Debug level logs are enabled. So you can see a lot of extra logs. So after every 5 seconds, you can see the polling is happening. The database poller. Which thread is actually polling? See, it is not a thread from Uber thread pool or any other thread pool. It is actually a separate thread pool. Uh, Here you can see something like polling source and all. Remember, the message source will not use this core CPU light or CPU intensive or IO thread pools. Every message source will have its own thread pool. While explaining about HTTP, I told that there will be a Grizzly thread pool. HTTP listener will use its own thread pool called as Grizzly thread pool. We'll discuss more on Grizzly next. So every source, remember, very important for interviews. Every source will use its own thread pool. So here in this case, on table row will use a thread of its own, and this is the name. Okay, so it's polling after every 5 seconds. See, fine. I'll clear the console now. I'll go to my database and I'll try to add some product into this product table. Product ID 100. Brand name is Siva. Description, some description. Name, some name. Offer price 1. Apply. Fine. Now let us see. One row is updated. See, once the poller is polled, here you can see Uber 03 has executed. Got name as, where is this got name as? I think here I'm writing this log in the transformer, right? Got name as, it is executed by a separate thread. Here you can see in the logs which thread has executed Uber 03. But what type of operation is it? Here you can see CPU intensive operation. And again, Uber 8, this is blocking IO operation. This is from, I guess, yeah, I guess this is from database component. So you can see thread switching, right? You can see thread switching. Fine. Now, if everything has gone right, I should see one row in product table and I should see one more row in DB1. Let us check in copy product. Hey, there is no record in copy product. There's no record in both. Fine. How come? Exception was not thrown, right? I didn't pass a brand name as Samsung, so exception was not thrown. Uh, just a minute. Ah, okay, don't worry. It's configured here. That's the reason. I will change it and I'll tell you what it is. There is nothing related to transaction. Assume that I have not done anything. I'll talk about transaction configuration just in few seconds. Let it redeploy. And when it is redeploying, let me do one small thing. I don't want debug level logs. Too many logs are coming. I change the log as info. Info level logs only will be written. Actually, I need just a minute. Here in the insert, I will not see this logs of insert component if I don't enable debug. Okay, I'll make it debug. Fine, let it run. I will tell you. Let it launch. So I'll go to Mule Training DB products. I'll truncate this. Fine. Now, once my application starts, I will insert a row. I'll try to do something here. 200. Brand name is Siva. Some description. Okay. Let me wait until it starts here. Actually, this is not an exception, whatever you see. I have enabled debug level log. Internally, the library is just writing it. It is not an exception to be seen. That's okay. Now the application has started and it is polling after every 5 seconds. Fine. Now I'll go and insert it. Yep. Now you can see there are logs. Here you can see there are logs got name as and something like parsing SQL and all. You can see thread switching Uber thread 02, 03, 02, intensive operation, blocking operation, and blocking. Actually, this is a blocking operation from insert. It is inserting. You can see again inserting one more thread switching has happened. CPU intensive thread pool. I wanted you to understand that there is thread switching, and again the polling is happening. Fine. Now, what will happen if there is an exception? I want to simulate an exception by specifying the brand name as Samsung. If I give brand name as Samsung, this will throw an exception. If this throws an exception, what will happen? This insert could have been successful and this will throw an exception. This insert could have not been successful. Okay. First of all, let me go to database and check in DB1. Is product having? Yes, now product is there. Copy product also? Yes, it is there. Fine. Now, let me simulate an error condition by inserting one row where brand name will be Samsung. Brand name I gave as Samsung. Some values I'm inserting. Apply. Now just observe there will be an exception or error simulated. So insert, you can see inserted into product table, but I don't see an insert into copy product table. Okay. Thread switching, everything has happened. But now if I go to see my database in DB1, product table is having how many rows? 2 rows. But copy product, oh, that means this is successful, but this is not successful. Now, what I want is if everything should be either committed or everything should be rolled back. If an exception is thrown here, whatever is inserted by the insert component should be rolled back. So I want to run this entire logic in a transaction. So wherever you want a transaction to start, what you can do is you can wrap that in try scope. I want these three components to run in a transaction. Either everything should be successful or everything should be rolled back. So I have to wrap this, and in the try scope, I have to specify transaction action as always begin. I will write always begin. That means whenever control is coming to try scope, we want to begin a transaction. And what type of transaction is it? Local transaction. Hey, don't worry. We have a separate topic of transactions, transaction management, where we'll talk about how to handle global transactions, local transactions separately in a separate topic. It's a bigger topic. But right now, I'm not talking about global transactions. If a transaction is spanning across a single database, in this case, it is a local transaction. See, insert component is writing to which database? DB1. This one also is writing to DB1. So if you want a transaction across single database, it is a local transaction. We'll talk about global transactions later. Right now I specified transaction type is local and always begin. And remember, if some exception occurs, transaction has to be rolled back, right? Remember, if transactions have to work, a single thread should execute all these components. I don't want thread switching, right? And I configured my try block to actually use always begin a transaction. What will happen is all the components in this try scope will be executed by a single thread. That is taken care, right? If there is no transaction, thread switching will happen. But if you configure a transaction, here I'm specifying in try block, I'm asking it to always begin a transaction. So if there is an exception in the try block and I'm not handling it, whatever data has been inserted, it will be rolled back. If no exception, then everything will be committed to database, right? So in case if transaction is running, all this will be executed by a single thread. Let us see now. Okay. I think I just need to say where automatically it will get redeployed. Let it redeploy. Still it is deploying. Okay. Fine. Now I will insert one more row into product table 202. Again, I will insert Samsung. Okay. I will apply the change. Finish. Now, see, insert was done only on product table. The control even didn't come to copy product. Exception was thrown. Transaction could have been rolled back. And I want you to observe that this thread number is 6. Same thread has executed the entire components in the flow, right? All the components in the flow will be executed by single thread. Fine. Now let us see the transaction is it rolled back. In product table, hey, there are only 2 rows. The new third row is not inserted. Here, there was only 1 row. Earlier also it was rolled back. So transactions are working, and I wanted you to understand that all the components in this triscope would have been executed by same thread. Okay, now if I keep this also, same thread could have executed everywhere. Okay, so that's the concept which I want you to understand. Okay, now what you have to do is you have to go to my GitHub. The GitHub link is provided in the description of this video. Download the GitHub repository, and in day2 folder, you just follow the exercises given. So please proceed to the next video only once you complete the exercises. Without completing exercises, without doing it on your own, you will not get confidence. See you next lecture.